Okay, in this video we're going to be talking about rational functions and their graphs. Okay, so an example of this is going to be something like this. So this time we're throwing some x squareds in it. Instead of it being 1 over x, we could have x's on top, we could have x squared in it. So it's going to be a little bit different where p of x and q of x are polynomial functions. So we have equations on top and bottom instead of a number being on top and your x being on the bottom. Okay, so continuous graph has no value of x that makes the denominator 0. So no value that I put into the bottom is going to make a 0 happen on the bottom. It has no jumps, holes, breaks, asymptotes type of thing in it. So you're, an example, when you're graphing this graph, your pencil should never leave the paper. Okay, point of discontinuity, the spot that creates a hole in your graph. Okay, so continuous means the graph should never have a hole. If it does have a hole, it's called a point of discontinuity, okay? It discontinues. It stops continuing, okay? So a lot of these times it's going to be when your denominator equals 0. So if we can talk about, if we're breaking it down, removable discontinuity means if I have the same thing on top and the same thing on bottom, they cancel each other because they're the same. Just like 3 over 3 cancels each other. That is being removed. So we call it removable discontinuity. Non-removable means, okay, if I get a 2 in the bottom here, 2 minus 2 is 0, okay, that means it's discontinuous, but we cannot remove that x minus 2 like we did in the top one. So this is called non-removable discontinuity, where we get a 0 on the bottom, but we can't remove it. Okay, so we're just finding the points of discontinuity. So this whole lesson we're going to have to be factoring to figure out if we can cancel on the top and the bottom. Okay, so if I zoom in here, if I were to factor, remember it's what multiplies to get me this, adds to get me this. So I have x plus 3 on top. This is going to be x minus 3 and x minus 1. Okay, so my spots of discontinuity for this is going to be at 3 and 1, because if I plug 3 in here, it gets me 0. If I plug 1 in here, it gets me 0. Okay, I didn't remove any of them, so both of these are non-removable discontinuity. So my domain is negative infinity to, the first one that pops up is going to be 1, and then I go from 1 to 3, and then 3 to infinity. Okay, so if I were to graph that, the holes that happen are at 1 and 3. So I need to include everything in between 1 and 3, which is this one, everything to the left of 1, and everything to the right of 3. Because on our number line, we would go negative infinity, then we would hit 1, then we'd hit 3, and then we'd hit positive infinity. Okay, so my next one here, I cannot break this one down any further. So I try to think of a number, if I put it in here, will I ever get 0 on the bottom? Well, the first thing I think of is negative 1, because negative 1 will cancel out that 1. Problem is when I put a negative 1 in here, negative 1 squared is 1. So any number I plug in is automatically going to become positive, so there's actually no discontinuity. Because there's no number that when I plug it in the bottom, it's going to get me 0. So that means my domain, I'm not going to have any discontinuity, so that means from left to right I shouldn't have any holes or asymptotes. So it goes from negative infinity to positive infinity. Okay, my next one, we got to factor out this top. So I got y equals x, it's going to be minus 4 and plus 1, because what multiplies to get me this, adds to get me this. So I have x minus 4 on top and bottom, so they cancel. So my removable discontinuity is x equals positive 4, because if I plug a positive 4 in here, 4 minus 4 gets me 0. Okay, there's no non-removable ones because there aren't anything left. So that means my domain this time is negative infinity to that 4, and then 4 to a positive infinity. Okay, my next one here, if I factor the top, remember there's a 0x that sits right in here, so it multiplies to get me negative 1, adds to get me 0. So I got x minus 1 and x plus 1. My bottom, I can't simplify anymore, so x squared plus 3, so nothing is canceled. So I try to think of something that if I plugged it in for this x, it would get me 0 on the bottom, and because it's a squared, Any number I plug in there, I should be good. So there's going to be none on this one. So that means my domain, because I don't have any discontinuity or any holes, should be negative infinity to positive infinity. Okay, my next one, I got x plus 1 on top. My bottom, what multiplies to get me 2, adds to get me 3, so x plus 2 and x plus 1. So I have removable, because I removed it, discontinuity at x is equal to negative 1. And then I have non-removable at x is equal to negative 2. Because when I plug negative 2 in, I get 0. When I plug negative 1 in, I get 0. Okay, my domain this time is, I have to include these right here, so I go from negative infinity. I hit that negative 1. I go from negative 1 to that next point, which, I hit negative 2 first. Then I hit negative 1, and then negative 1 past that should be to positive infinity. So I need to include everything in between negative 2 and negative 1 and past those negative 2's and negative 1's. Okay, vertical asymptotes, they occur at non-removable discontinuity. Okay, so these are going to happen, and it's going to become x equals whatever that a is. So x equals whatever that non-removable discontinuity is. A hole is going to occur for removable discontinuity. So there's a lot to remember in this. Okay, so holes are, when we remove them, it makes a hole. It's like if you think about when you're moving an object, it's going to create a hole somewhere. Okay, non-removable, it's just going to create the asymptote that's going to go vertical, so that dashed line that we've been creating at whatever that number is. Okay, so this one, I don't have anything to cancel, so I have no holes, because holes would be the removable, but my vertical asymptotes are going to be at 2 and 3. Because those are, if I plug 2 in here, I get 0. If I plug 3 in here, I get 0. Okay, my next one, I have no removable ones again, so I have no holes. So this one is going to be at 1 and negative 3 this time. Okay, so these are the dashed lines that go straight up and down, because vertical, remember, is up and down. X equals lines are up and down. Okay, this one we can cancel, so I'm going to have a hole at 2, so that's going to be a line that's literally going to have a hole in it, and it's going to keep continuing. Okay, it's going to be at space where my line does not go in. It creates a hole, and that's at x equals 2, sorry. And then I'm going to have my vertical asymptote at x equals negative 3. So there'll be a dashed line at negative 3. Okay, my next one, it looks like I got to factor that top. So it's going to be x minus 1, x plus 1 over x plus 1. So these cancel, so I'm going to have a hole at x is equal to negative 1. And then there's not going to be a vertical asymptote for it. Okay, so horizontal asymptotes, here's the key thing to remember, and it's super confusing. Okay, so when we're talking about m and n, those are the degrees. When I talk about degrees, that's going to be what the exponent is. So m is going to stand for the numerator one, so the exponent on the top. N is going to stand for the one on the bottom. Okay, so if your exponent on the top is smaller than the exponent on the bottom, then your horizontal asymptote's y equals 0. If your exponent on the top is bigger than the exponent on the bottom, then there's not going to be an asymptote. If they're the exact same, so x squared over x squared, it's going to be the fraction of the coefficients. Okay, so an example of this for my first one, if m is going to be less than, so that would be if we had x over x squared. The reason that I remember this is if it is bottom heavy, because the bigger number's on the bottom, you're hitting the bottom of the ground. Okay, the ground is at 0 feet, 0 inches, whatever you want to think of it at. So if it is bottom heavy, it's going to be y equals 0. Okay, my next one, if it's top heavy, that's going to be x squared over x. If you want to think about it this way, you can think about the fact that x squared divided by x gets me x, in which case I wouldn't have anything on the bottom, so I won't have the horizontal asymptote in this. Or if you think about it, this is going to be a top heavy situation. So if you are top heavy, you're not going to have an asymptote. Okay. And then in class I can explain another way to remember this. If they are equal to, so that would be if I had x squared over, let's say, 3x squared. So they're the same. So if we think about it, they're going to cancel each other, and then that 1/3 is what's going to be the asymptote. So if they're the same, it's whatever the fraction is or the numbers in front of those. Okay, so my first one, they're the same, so we look at the fraction. So it's going to be y equals, it got a 2 in the front of the first one, a 1 in the front of the second one, so y equals 2. Okay, my next one, I am bottom heavy because I have a 2 here and a 1 here. When I talk about degree, it's always the highest exponent on the top and bottom. That's why I'm not worrying about the rest of this stuff. I'm worrying about the thing that has the biggest exponent. So if it's bottom heavy, remember you're hitting the ground, so y equals 0. Okay, I am top heavy this time. I forget about this. Top heavy, we shouldn't have any asymptotes. Okay, so we're finding the vertical asymptote, the horizontal asymptote, and if they have any holes. So first off, let's go ahead and factor. So what multiplies to get me negative 12 adds to get me 1. So x plus 4 and x minus 3. My bottom, what multiplies to get me negative 4, but when I add it gets me 0, is going to be x minus 2, x plus 2. Okay, so I don't have anything that cancels, so I'm not going to have a hole. But I know my vertical asymptotes are going to happen right here. So it's going to be at x equals 2 and x equals negative 2. Vertical, remember, goes up and down. That's why it's at x equals. So I'm going to go ahead and do the 2 and the negative 2. Okay, and then horizontal, we look at the degrees. If they're the same, you use the numbers in front. So I got 1 and 1. So 1 divided by 1 then is going to be 1. So my horizontal asymptote is going to be at y equals 1. And horizontal, remember, is like the horizon, left to right. That's why it's y equals. And I didn't have any holes. So my next check is to check my graphing calculator. When you type it in your graphing calculator, remember to get the table values to fill in the rest of the points. You have to do second and then graph. And then make sure when you do this, you put this in the parentheses and this in the parentheses so that it's on the top and the bottom. Okay? Otherwise, it's going to do your division really, really weird. So I type in x squared, parentheses, x squared plus x minus 12, end my parenthesis, divided by, start my parenthesis, x squared minus 4, end my parenthesis, and press graph. Okay, and then it looks like it's crossing at 0, 3 right here. So it's going up kind of like this. This one is crossing at 3, 0, so 1, 2, 3, 0. So he's shooting off like this. And the other one is crossing at negative 4, 0. Coming around like this. So that is kind of what your graph's going to look like in this. If we would have had a hole, let's say the hole was right here, it would literally just be an open circle. But we don't in this situation. Okay, so my next one, let's go ahead and factor first. So my top, I got x minus 2, x plus 2. My bottom just has a GCF that we're going to pull out, and it's 3. So if I divide both of them by 3, it becomes x minus 2. So I have a removable discontinuity at 2, so I'm going to get a hole at 2. I don't have anything else left down here where I'm going to have a vertical asymptote, so that's going to be a none. My horizontal, I check the degrees. If it's top heavy, we don't have one, so it's a none. So let's just go ahead and type it in our graph. So I got y equals, remember to put these in parentheses so that they're on the top and the bottom together. So x squared minus 4 divided by 3x minus 6, and my parentheses. I'm going to graph it. This is going to look like a straight line, and it's going to have a hole at positive 2. So if I press second table, I got, let's zoom them in here, negative 5, negative 1, 1, 2, 3, 4, 5. I got negative 2, 0. My error occurs at 2, so when I start connecting all my points, I'm going to have a hole at that 2. My next one, I got 1, 1, I got 4, 2, 2, 3, 4, 1. And then the hole should occur at 2, so right about here. So your graph should look something like this. Okay, you're not going to see this hole on your actual graph on your calculator, so you just need to be aware of where that 2 is occurring at.